They're everywhere, on rooftops, in basements, in the walls of the buildings where we work, live, and play. Commercial air handlers, the invisible lungs of modern infrastructure, moving massive volumes of air to keep our most critical facilities in operation. But behind their hum lies a harsh reality, an extraordinary waste of energy. In the US alone, HVAC systems account for nearly 40% of the energy used in commercial buildings. Many of these systems are stuck in the past, relying on oversized motors and outdated designs, losing efficiency with every spin. One innovative approach is challenging the status quo by reimagining the heart of HVAC systems that delivers greater efficiency, reliability, and control.
To me, efficiency is your admission ticket. If you're not solving energy challenges, you're not really even in the game. You can have the most efficient fan in the world, but if you truly want to offset power and reduce total power consumption on a big scale, you have to get them in buildings. When I first started and we were building custom air handling units, I remember, using our overhead crane and rigging just massive fans with 100 horsepower motors on it. I mean, the assembly of the fan itself was probably, over 2,000 pounds. These things are enormous. We adopted a new technology that was coming from Germany. These new plug fans were really lightweight, and no one was really using them at the time for commercial air handling units, and we didn't understand why. We immediately adopted them, applied them, and started putting them in our air handling units. It was making our air handlers smaller where they could fit in tighter spaces. Our entire product fit through a door. We knew that there was something there because the fan we replaced was enormous. And historically, you would run all the power and all the wires back to a single location external to the air handler at an industrial control panel. We just thought okay, how can we shift the electrical burden to a factory? We came up with this junction box. We called it a quick connect box. And all it really did was it gave us a predictable location in the assembly process. That little junction box, I don't think any of us expected the impact it would have. So the problem shifted to the world's best kit fan that can be assembled in the field with minimal training and competencies. And we just tried to make it as radically easy as possible.
So an installer would cut out the existing fan into pieces if they have to and get it out the door. And then they would carry in our sheet metal frame. You start putting in the different panels and they're numbered and they all interlock together. And then once you get the frame in solid, you could put the harnesses on next. We've made it so simple that the same team that's tasked with putting the fan together is tasked with putting the harnessing on. And then ultimately the scope of the electrician only relies on them wiring from here to our control panel. This is really what makes Q-PAC special. This is what unlocks all the potential, is we basically take a set of motors and treat it like a single fan, and that's what this does.
Not only are these fans smaller and easier to install, they offer resiliency, which means if one fan fails, the others will seamlessly pick up the slack. This offers energy savings with lower operational costs. But the real effects of the efficiency are because each fan has gone through thousands of automated quality control tests before it ever leaves the factory. This saves facilities countless hours on installation and also future-proofs the system for generations to come.
There's a lot of automation at Q-PAC in general. What this allows us to do is pretty special. When an operator in any cell that needs to test the product, they hook it up, inputs and outputs, and the custom product we've built using the Schneider PLC and HMI allows us to just press start and it does a run check. It checks through every single conductor and just tries to simulate a real world environment. And a lot of these are critical applications. They might be operating rooms or schools. So it's very important that we get this right.
That's the fan controller. We need to make sure that it leaves and it's got no issues with the wiring. We built this instrument here ourselves. You can hook up all the inputs and you simulate as if it has all of the motors in the system and that it's getting inputs from the customer externally. And that way we're able to do a full run test here and find any problems that it might have. I mean, this allows us to do our quality control process in such a fraction of the time that it would take to try to test that in any other way. It's a game changer for speed and being able to deliver as fast as this company can.
Innovations today make tomorrow a reality, but it doesn't come easy. Disruptors like Q-PAC cannot just make a change once. They must be continually striving for the next horizon, enabling a more competitive, resilient future for newer and newer industries to come.
We're talking big numbers. Fans alone are somewhere between 15 and 20% of the total building's power. So we have a chance to cut that in half. Facilities are very complex. Engineering around facilities and just the built environment in general is going to evolve greatly. We are continuing to focus on the facility teams that maintain buildings that are highly occupied. The market for AI and data centers is so big that we are getting applied there as well. And I think where we are today with technology, there's a tremendous amount of room for improvement. My industry of the future is more efficient buildings and consuming less power and higher air quality, all the benefits of adapting to that environment and minimize the waste that's involved. We see a whole new chapter coming. We're just at the very beginning.